Greetings and salutations. As you can see here, we are given a problem. The diagram shows a roller coaster car at the start of its track. This is the roller coaster. At letters A to G indicate the position of the car at certain stages during its journey along the track. The car is stationary, not moving, at point A. It takes 10 seconds for the car to reach point B. As the car passes point B, it is traveling at a speed of 2.5 meters per second. Calculate the acceleration of the car between point A and B. Include the unit as your answer. So we are focusing on the point A and B. When it comes to acceleration, what is our formula? Our formula is final speed, take away our first speed, and then you have to divide that all by the time. So looking here, our first speed is 0 because we are starting at A. So our first speed, we'll just write 0. And then our final, they tell us the final speed is 2.5 meters per second. And then they tell us the time that it takes to do so is 10 seconds. So really, we can just put this all together. Our final speed is 2.5. Take away 0, our first speed. All over the time taken is 10. Now take that away, 2.5 all over 10, and then that is going to equal 0.25 meters per second, and you can box that. And that would be your answer. The 4 graphs below, A, B, C, and D, describe the motion of different objects. Then the question comes, use the statements below to describe the motion of the object in each of the 4 graphs. Note that one statement should be used twice. We're given 3 statements and we have to match them to each graph. So the object did not move. So the object did not move. Which one of these graphs would tell us that the object did not move? Well, in A, the distance is accelerating. The distance is going while time is 2. So that can't be it. For this one, time is continuing to fly by, right? Time is passing on, but the distance isn't. So this would match the statement of the object did not move. The first statement, it should match graph B. So you can just write the number 1 right there. Now for the second statement saying the object moved with constant speed. So if you look at any of these graphs, which one tells us that the object is moving with constant speed? Graph D is, because we are at the speed and it is moving constantly. You are not increasing and you are not decreasing. It is going constantly in a straight line. So that tells us that graph D follows statement 2. Now with the third statement, the object accelerated. The object is accelerating. If we look at graph A and C, the distance is increasing, but so as time is passing. So the object has to be accelerating in this graph. Now with graph C, the speed is increasing. It is accelerating as well as time is passing. So for graph A and C, statement 3 matches each of them. The graph below shows the speed of a car changed with time during a journey. So here's the speed, here's the time. So the car at first, at point A, it is not moving. Well, it's going with the same constant speed. Then suddenly it is accelerating, then it is deaccelerating, and then going at a constant level of speed. So for the first question, it's asking us, what is the maximum speed of the car during the journey? Okay, so we would have to look at our graph and see, well, what is the highest point? If we were to look at point C, and we were to just, now please use a ruler. I am not using a ruler, but if you are doing this, please use a ruler. If we were to look right across, 30 would be our maximum speed. Your answer is 30 meters per second. Remember, we're using the unit of speed. Now it's asking us to calculate the acceleration of the car between point positions B and C. So remember our formula for acceleration. It is final speed take away first speed all over time. Okay? So for B and C, point B would be considered the first speed, and then point C would be considered as the final speed. So the first speed, well, it's 15. So our first speed is 15 meters per second. And if we were to look at point C, it's 30 meters per second. So our final speed then is 30 meters per second. But they don't tell us the time, or do they? They actually do. So between point B and C, if we were to go straight all the way down, it is labeled time. It is going up in 20s. And the unit is seconds, okay? So the gap between point B and point C, we have to look at the time within that and just within this frame, okay? So 60, so you would need to do 120 seconds, take away 60 seconds, and that would be 60 seconds. So then your time would be 60 seconds. Perfect. So now you can put these all together and you can solve. So our final speed is 30. So 30 meters per second. Take away our first speed, which is 15 meters per second. And then our time taken for that is 60. That should give us 0.25 meters per second. Now in the next question, they're asking us to describe the motion of the car between positions C and D. So we are not doing any mathematical calculations this time. We have to describe in words of the motion of the car between positions C and D. Now, if we were to look at the positions of C and D, how would we describe this? So you could say that the motion of point C and D shows that it is slowing down. And you could say that this process is called deacceleration. Deacceleration in this case is our key word, and that is what they are looking for. So you could say the position of C and D slow down. And then you could state that this motion is called deacceleration because this is the key word they are looking for. In the next question, they're asking us to describe the motion of the car between points D and E. Okay, if you look at our graph once again, D and E is right here. So how would we describe this? Well, what do you see? Well, what I see is a straight line between D and E. And this is shown on the speed. So this means that it is going at a constant speed because, well, it is not increasing, it is not decreasing, it is staying at the same speed of 0. So you could just say that it remains at the constant speed. Or in other words, you could say that it stops, but we need to refer this with key terms within our graph here. So the motion, you could say the motion remains at a constant speed. It remains at a constant speed. And then you could state again, this is shown by a straight line between D and E. And that should get you full marks. Now we are given another graph. The graph below represents the journey of a cyclist, okay? So we look at, there are points A to E. From A, it is the distance and time is increasing, but then between points B and C, it is staying constant. And then D and E, it is suddenly accelerating. And then to D and E, it is slowing down, or in other words, deaccelerating. So here they're asking us, name an instrument that could be used to measure the time taken for the journey. So with this, for example, if you're on a run, if you're running through the park, what instrument or what device would you use to see how long it takes for you to take that run? You would usually use a stopwatch. It's the same with here. We have to use an instrument, aka the stopwatch, is used to measure, calculate the time taken for that journey. It could be for a run, it could be for a cycle, it could be for a car drive, anything really. So your answer just could be stopwatch. Now obviously there are other answers too. Now they're asking us, calculate the average speed of the cyclist as he traveled from point A to point B. Okay, let's look at point A and point B. So A, we are starting at 0, and then we are suddenly boosting all the way to 100. In this case, we are told that we need to figure out the average speed. So we are given the distance, we are given the time, we need to find the speed. So to do so, what is the distance of A and B? You're starting at 0, your final distance is 100. So your distance is 100 meters. Then your time taken for that, if we were to just cross point that, now your first time is taken from 0 and then to 40. So your total time is 40 seconds. Now with this, we need to find speed. How do we find speed? Well, we would use our triangle. Dunstores trolleys. Distance, speed, and time. So to find speed, we have to divide that. So we have to divide distance and time. So our distance is 100, and we would divide that by 40. And then what would we get? We would get 2.5 meters per second. Do not forget your units. And that is your answer. Now, describe the cyclist's motion between points B and C of his journey. So we have to describe the motion once again. So from point B and C, well, the distance, it's not moving, but time is. So that means the person, the cyclist, is staying put. They are not moving. So you could just say the cyclist. You could say the cyclist is at rest, the cyclist is stopping. It's all the same. So the cyclist is at rest. The next question that they're asking us is the cyclist's speed as he traveled from point A to point B was less than his speed as he traveled from point C to point D. So what they're doing here is they're comparing, okay, the speed from A and B is much more less than the speed from C and D. And we can just see that. From looking at this graph, we can tell that that is true. Because this line, the line is much more steeper. So that tells us that the gradient is much more steeper, which also tells us that the speed has increased by a lot. It has accelerated. So we can tell that that statement is true. What evidence is there in the graph to support this? And I just gave the answer. Say the slope, so you could say something like the slope of the graph between points C and D are steeper. And it is also a larger distance than traveled in short time. But we can just keep this simple. You could say the slope of points, the points of C and D on the graph are much steeper. You could say showing that it has accelerated. Showing that it has accelerated. You don't have to fill in the whole box, just fill in as much as you can. Next, they're asking us, describe what the cyclist did at point D. Okay, so we have to look at point D. So from point C to D, okay, they're accelerating, but suddenly they're dropping down. So you could describe this as, well, the cyclist began to, return to the starting point, because you're starting at the distance of 0. Okay, you're going up, you're accelerating, and then suddenly you're going all the way down. So that means you are starting all over again, to your starting point. So you could say, the cyclist, and do mention things from the graph. For example, the cyclist. Don't just say that, on the graph it shows this, that. You have to relate to what the question is saying. So the cyclist began to return to the starting point. You could say it as simply as that. The cyclist began to return to the starting point. And then these answers should give you full marks. And that is that. Thank you for watching.